Okay, the next part now we're going to look at is, in particular, thing about gases and gas pressure. Okay, pressure is a force per unit area. Okay, and gases exert pressure on any surface they collide with. So anything it collides with, whether it's a container or whether it's something else, whether it's another molecule or whatever, they exert what we call pressure, which is just so much force, okay, or so much push per a certain area. Okay, in particular, we have air pressure. Okay, air pressure is the atmosphere or the molecules of air, okay, exerting pressure as it moves. We have at lower elevations, okay, so like lower elevations would be like here in Ohio versus say out in Colorado or somewhere out west in the mountains, okay, we have more particles of air down by where we live than they do in theirs. Okay, so their atmospheric pressure is less than what ours is, and that affects how things boil. And we'll look at that later on in this chapter, okay? So now we're going to measure air pressure. And the thing that we use to measure air pressure is called a barometer. It's spelled bar-o-meter, but it's pronounced barometer, okay? And there's a picture of one in your notes here on the right, okay? And this is a pool of mercury down here, okay? And the symbol for mercury is Hg. We'll learn that later, all right? But this is a pool of mercury down here. There's a bunch of mercury in this tube, okay? And this tube is closed right here at the top. And so you take a tube, think like a test tube, okay? Although these are a lot longer and a lot skinnier. But you think, for example, take a test tube, turn it upside down, okay? And you're going to put it in this pool of mercury. Now what they do, okay, is they kind of fill this test tube up first with mercury and then put it upside down because you don't want any air in this tube, okay? And now the air pressure, so all the air around us, okay, will push on this open pool of mercury. So they push down on this pool of mercury, right? And if you have a lot of atmospheric pressure, it'll push down on that pool and then it'll go up the tube, okay? And it'll go higher up the tube will be a higher atmospheric pressure. If there is less atmospheric pressure, there's not as much pushing down right here, okay, then it's not going to be as high of a reading, okay? Because how this tube and this pool works, the mercury in the tube falls down until its pressure is equal with the pressure on the outside. Because you're not going to have unequal pressures, okay? Because if there's unequal pressures, it's going to keep pushing until they're equal, all right? So the outside pushes down, the inside kind of falls to match that, and then you read the atmospheric pressure. So it's all about how much pressure is pushing down on this pool that then pushes up this skinny tube, and you then read it. So that is a barometer. A barometer measures air pressure. Now you often want to measure other pressures that aren't just air. So say I want to measure the pressure of some neon gas in a container. We use what's called a manometer. Okay, manometers measure enclosed gas pressures. Okay, these are both manometers over here. All right, and the difference in the height of this liquid, okay, that's in this tube, is their gas pressure. So you've got a gas in here. Okay, I've got these equal levels, and there's nothing else in here. We open this up, the gas leaches out, and it starts to push down on this arm right here. They're called arms. Okay, so the liquid in this arm, well, that pushes this end up, okay, and the difference between the two levels is how much pressure is in this gas, or in this container. If there's lots of gas particles in here, okay, then this difference is going to be a lot bigger. If there's not much difference in there, then they're going to be, or not much pressure, then the difference is going to be a lot less. Okay, so we have talked now about how to measure gas pressure. I haven't yet to mention what units we use to measure these gas pressures, okay? A lot of times for other pressures, when we deal with stuff for physics, we're talking about a Newton, okay? And here, for gases, we do not measure in those. You can, but we don't. We often measure in what's looked at as mmHg, which is millimeters of mercury, because mm is millimeters, and Hg is mercury. So millimeters of mercury. And the reason that unit came about is because of the barometer. The barometer had mercury in it, and you would read the little lines. They were in millimeters, and you'd read how many millimeters of mercury were there. You can also measure gas pressure in what's called torr, T-O-R-R. It's named after a guy with the last name of Torricelli, who kind of first worked with a barometer and first came up with the idea of how to measure air pressure. You also can measure in what are known as kilopascals. PA is for Pascal, who's another person. Okay, and the K just is like a kilometer. Okay, means 1,000. You can also then measure in pascals, which are just PA. All right. If you think of a little more common units, you can also measure in things like bars or PSI. PSI is probably the most common one we have around here. We tend not to measure in those for chemistry. We tend to go more with the torrs and millimeters of mercury. The other one that is the actual SI unit for measuring gas pressure is called an atmosphere. All right, and there are a bunch of things that equal an atmosphere. You could have 760 millimeters of mercury. You can also have 760 torrs. You could have 101 kilopascals, or 1.01, because you're going to move it 3 places, times 10 to the 5th pascals. Those all equal one same thing. They all equal 1 atmosphere. So all of those units all are equivalent, and they all equal just 1 ATM, or atmosphere. Okay, the last thing we're going to look at here, other than a simple problem, is that to compare volumes of gases throughout the year, okay, I have to know the temperature and pressure at which your volume is measured, because as we'll look at later on in the year, they change based on your temperature, pressure, volume. Okay, so we look at what's called STP, which is standard temperature and pressure, and that's when you have 0 degrees Celsius and 1 atmosphere. Okay, so we tend to look at gases as all being at the same thing called STP if we want to compare them, and that's 1 atmosphere and 0 degrees Celsius. Okay, now we're going to go ahead and try and convert some units. All right, so I want to convert the average atmospheric pressure in Denver is 0.830 atmospheres, and I want to express this in torrs, millimeter of mercury, and kilopascals. Okay, so I just told you that in 1 atmosphere there are 760 millimeters of mercury. We have less than an atmosphere, so my number needs to get smaller. There's a couple of ways you can do this. Right now I would just think that I need to multiply, because I need to know how much. Okay, and it should be just under 760. Okay, so I know that I got to multiply by 760 because there are 760 millimeters of mercury in an atmosphere. And I'll get my answer to be 631 millimeters of mercury. All right. You can also then know that's the exact same number of torrs, because torrs and millimeter of mercury are the same, 760. Okay. If I now want to look at kilopascals, I might say, okay, I've got 0.830 ATM, and there are 101 kilopascals in an atmosphere. So again, I should have just under 100. So again, I got to multiply by 101. That's actually like 0.325. I can use like 0.3 or 101 is good enough. And I know it's going to be 84.1 kilopascals.